Hey students, today we're going to get into chapter 10. And chapter 10 basically combines our last 2 or 3 chapters where we talk about proportions and means. So this lesson is about comparing two proportions. And by the end of this lesson, you should be able to describe the shape, center, and spread of a sample proportion, where we get the difference of those two sample proportions. And you should determine whether the conditions are met for doing the inferences, as in making predictions about the entire population, given the information we have. You also can construct and interpret a confidence interval with two proportions, and you can perform significance tests. All right, let's get a warm-up question. And this comes from the practice test. So pause the video, read this question, and just what you already know, answer this question as best you can. All right, so hopefully you pause the video. Hopefully you came up with an answer choice C. In order for those two to be the same, well, if we want to check see if there's a difference, we should have accepted our null hypothesis was that there was no difference, as in the brand name and the generic. If you subtracted the means, you get 0 because there's no difference between them. And ultimately, we don't want to know whether or not it's greater than or less than. We do want to know, though, if it's not equal to each other, not equal to 0. So in this case, it's a two-tailed test because the brand, maybe generic is better, so forth. So we would choose answer choice C for that question. I suppose we want to compare the proportion of individuals with certain characteristics in population 1 and population 2. Let's call these parameters of interest P1, P2. The ideal strategy is to take a separate random sample for each population and then compare the sample proportions P hat 1 and P hat 2 with those characteristics. What if we want to compare the effectiveness of treatment 1 and the treatment 2 in a completely randomized experiment? This time, the parameter P1 and P2 that we want to compare are the true true proportions of successes of outcomes for each treatment. We use proportion of successes in the two treatment groups, P hat 1 and P hat 2, to make our comparison. Here's a table. So basically, here's our treatment 1, here's treatment 2, here's the entire population statistics, and here's the sample set for statistics of the proportions. This is the sample sizes 1 and 2. So we compare the population or treatments by doing inferences about the differences of P1 and P2 between the parameters. The statistic that estimates this difference is the difference between the two sample proportions, P hat 1 subtract P hat 2. To use P hat 1 subtract P hat 2 for inference, as in make a prediction about the entire population, we must know its sampling distribution. We got to know, is it random? Has it been done randomly? Was it random? Was it done normal? And is it independent? The same thing we've been doing for a while, so it's not new. But except this time, we're going to test it for both samples, opposed to just one. Take a minute to read this paragraph. Pause the video and read it through, and then we'll talk about it next. All right, hopefully you're ready. Basically, at school 1, 7% of students did the homework last night, and only 50% in school 2. So we look at that on if we actually look at that data, and they created with software like 1,000 times. Here's school 1. Notice the mean there's that mean proportion is 70%. Here's school 2. That mean proportion that's 50%. And here's the difference. P hat 1 subtract P hat 2. Notice how that mean, the number in the middle there, is 0.2. It's basically 0.7 take away 0.5. So it gives you that difference there as we subtracted those two proportions. It's a big idea of this whole section. All right, let's go back to shape. In order for the shape to be normal, we got to look for n times p to be greater than 10, n times the complement to be also greater than 10, and that goes for n1 and n2. So we got to check the second proportion. So n2 times p2 is greater than or equal to 10, and then n2 times 1 take away p2 is also greater than or equals 10. So we got to check those each time. And then we're going to check our standard deviation. Again, our standard deviation is also called our standard error. Standard error. And when we start talking about margin of error, keep in mind that standard deviation is only a part of the margin of error formula. So the margin of error equals to the z star, or in some cases t star, we're using the t distribution, times the standard error. Standard error. Times standard error, which is, if it's one sample, is just that standard deviation of that one sample. If there's a difference of two samples, it is a standard deviation of the difference of those two samples. So P1, P2. So keep in mind, our standard deviation formula, we get an extra step to it. We got the difference of those. You'll see that in just a moment. Let's go on. Oh, and yes, we only need this margin of error if we're talking about confidence intervals. So with my confidence intervals, we want to find that margin of error because we're going to find our point estimate, but we're going to find the ends to that confidence interval. Pause the video and take a minute to read through this example. Now, this is the data from the previous example, and this is just talking about the shape, center, and spread. So we should check the shape, and again, it's going to be 100 times, because our sample is 100, our probability was 0.7, and we basically check to see if those approximately normal for the first sample and the second sample. We check our center for the first sample should be p hat, or in this case, if we don't know the population, we use p hat to be the same thing as population, 0.7, and then the other one's 0.5. Our standard deviation, in this case, because we have proportions, we should use this formula for each of those standard deviations. We have this value. Because school one has population over 10 times 1,000 and so forth, all those things are checking out. So we have less than 10% of the population. So we pass the 10% rule as well. So for that reason, that would allow us to actually do the test and make an inference on the whole population with the data we have. Now, if I actually did try to make this value, I know my center of this normal distribution should be p hat 1 take away p hat 2. Which in this case was 0.7 take away 0.5, which is 0.2. So note that center there is 0.2. Our standard deviation, though, is a bit more complicated because we have two, we didn't have the difference there. So for that reason, we have to use the formula where we have to combine those standard deviations. So basically the square root of standard deviation for the first one plus standard deviation for the second one. All right, so you've seen, this should look familiar. It should look familiar. I hope it looks familiar. I hope you've seen that we actually done this before, where we actually combine different standard deviations underneath the square root symbol. And this is what it looks like. So here's my value of p hat 1 subtract p hat 2. And then here's my standard deviation, right? So that's my standard error for each one of those. And that's the mean. And that's what we already know. Now, construct a confidence interval. Once we know all those values, it should be pretty easy to construct that confidence interval. But again, we need to know our critical value. So to make the confidence interval, we're going to find all the things we already know. We're going to start off with our point estimate. In this case, it will be 0.2, plus or minus our standard error, the square root of all that stuff we just saw a moment ago. And that value is, well, we didn't calculate it. So going back, the first value for the first standard deviation, the standard deviation of 1 was 0.0458. So I'm plugging in that value here. 0.0458, and then plus the other one, which is 0.0354, 0.0354. Add them, square root them, and that should give you the standard error there. If you plug that into the calculator, 0.0458 plus the other one, and you square rooted it, you should get about 0.284, about 0.285. So that's standard deviation for p hat 1 take away p hat 2 should be about 0.285, roughly 285. And again, that standard error goes in front, so we got to know our confidence level to know our standard error for that value. So again, that's what it is. Hope you can read that. That says our point estimate, our statistic plus or minus standard error times standard deviation of those two combined. I think I mentioned this already, but it has to be random, 10%. I didn't mention large camps, but again, that just means you got to have a large enough, some large enough values that actually start counting it. And this next page just builds up where it comes from. Right, here's the standard error formula. Here's the formula I just talked about, where we actually get p hat 1 take away p hat 2, our point estimate, plus or minus the critical value, whatever that z-score is for that confidence level, times that standard error or that standard deviation. So the two sample z interval for difference in two proportions is given here. And there's a formula for it, where z star is a critical value for the standard normal curve with the confidence level given whatever we decide to be 99%, 95%, and so forth. And the area is between negative z star and positive z. Just keep in mind, whatever the critical value is when you calculate this, you use the positive value there. Here's an example from the textbook. We will talk about exactly how to do this, and how to construct that confidence interval today in class. But right now, pause the video, read the example, and see if you can find out what the confidence interval should look like. Like, see if you can figure out the point estimate here in the middle, the margin of error, the standard error, and everything you need. Pause the video and give it a shot on your own. Just keep in mind we will give you the answer for it. And we'll talk about how to use technology to do it as well. Hopefully you gave it a shot. Hopefully these values make sense. You came up with these values here, and you actually came up with the actual the interval here. Get the information they gave. For example, we should have found the point estimate pretty easily. Should have found the standard error, or standard deviation pretty easily. And we got 1.96. It sounds like a 95% confidence interval. So in this problem, they didn't tell you to use a 95% confidence interval. So I guess it's left to you assume to use a 95% confidence interval given this data. So given that 95% confidence interval, positive negative 1.56, you have found these values here. All right. So we're going to talk in a minute about making this plan and then stating what we're actually going to do. But I expect you to be able to do this much with what you already knew. Now, let's actually talk about using a calculator to do it as well. So use technology to do that. So use technology to do it. You're basically going to go to your test, to your calculator on, go to stats, go over the test. And we want to make a confidence interval. So you can go down to, say, 2 sample or 2 proportion Z interval. So in that problem, the X1 was 639, the N1 was 799, X2 was 150. And this number, N2 was 2553, and our confidence interval we chose is 95% confidence. We're going to calculate it. And if you notice, it gives us an interval between 0.07 and 0.14, given that information for it. So we can come up with our confidence interval given the calculator. We can use this on an AP Stats exam. You just have to tell the AP Stats exam, but you have to write down someplace that you're using a 2 proportion Z interval. And you can pretty much write out the data there, as long as you explain that's what you're actually using. And I'll write out all this stuff. I'll write down what X1 was, N was, all the values plugged in to actually do that, so they know you actually did it properly. All right, with that said, take a minute to read this example, answer the question using your calculator. This time, construct a 90% confidence interval. We'll compare answers in class. That's all I have for now. Good luck.